Some multiple choice questions may be asked from binomial distribution or part A questions. What are the things you may remember? You must remember mean formula. Your mean of binomial distribution is NP. Your variance formula NPQ. Using these formulas, we can expect problems in multiple choice or part A questions. Now, find the mean and variance of binomial distribution P 8, 1 by 2. 8, 1 by 2 means N is 8, P is 1 by 2. If P is 1 by 2, then Q is 1 by 2. Already we have studied the formula for mean equal to NP. Multiply N and P. So 8 into 1 by 2, it is equal to 4. Variance NPQ. Multiply NPQ. Answer is 2. You are tossing 10 coins simultaneously. Find the probability of getting at least 7 heads. At least the word is already used. At least mean minimum. Number of heads minimum 7. Minimum 7 heads means it may be more than 7. 7, 8, 9, 10. Up to 10 it is possible. So you are tossing 10 coins. What is the probability of getting at least 7 heads? 7, 8, 9, 10 heads. How to get? First you write what is your N, number of coins. Number of coins is 10. N value 10. Your N value 10. For coin related problems, the PQ are not given. You can assume P equal to 1 by 2 and Q equal to 1 by 2. Tossing of coin. Childbirth, male or female. So even though it is not given, we can assume that the PQ are 1 by 2. Number of coins is 10, N equal to 10, PQ, tossing a coin, getting head is 1 by 2, tail is 1 by 2. Next you write the probability mass function formula. Every problem you must write the formula. NCX, P power X, Q power N minus X. Here you may know N value, N is 10. So 10CX, P power X, Q power 10 minus X. If this is your probability mass function, then we can simplify. How to get this one? How we got this one? 1 by 2 power X, 1 by 2 power 10 minus X. So 1 by 2 power X plus 10 minus X. X plus 10 minus X, we can cancel X and minus X, we make it 1 by 2 power 10. So probability mass function is ready. I am going to find out the probability for X greater than or equal to 7. X is greater than or equal to 7. Minimum, at least. Minimum 7. Minimum 7 means 7 and above are permitted. X equal to 7, 8, 9, 10. There are 10 coins. Don't go beyond 10. So what is the probability for 7, 8, 9, 10? So probability mass function 10CX 1 by 2 power 10 formula. In this formula you are going to put each and every term. Then you simplify, you get the answer. 10C7 1 by 2 power 10, 10C8, 10C9, 10C10. Take the 1 by 2 power n common factor. Your common factor is 1 by 2 power n. After taking common factor outside, what is the remaining? 10C7, 10C8, 10C9, 10C10. NCR equal to NCn minus R. So we can use 10C7 as 10C3. It's also correct. 10C7, 10C3 both are same. 10C8 same as 10C2. After taking 1 by 2 power 10 common factor, you simplify the 10C3, 10C2, 10C1, 10C0 value. If anybody have calculator, you can take the calculator. I will explain how to find 10C3 using calculator. Those who are having calculator, you can take calculator. Manually we can do 10 into 9 into 8 divided by 1, 2, 3. You can simplify. We can also use calculator. First you type 10. Then you press shift divided by symbol. Shift divided by symbol. Your calculator will display C. Next press 3. 10C3. So your calculator will display 120. Your calculator will display 120. Then 10C2. Same method. 10C2. If you apply 10C2, it is 45. That number is 45. 10C1 is 10. 10C0 is 1. So let us simplify 120 plus 45 plus 10 plus 1. You add. So you may get 1076 divided by 2 power 10. 2 power 10 is 1024. Cancelling, we get 11 by 64. When 10 coins are tossed, what is the probability for at least 7 hits? Six dice thrown. You are going to roll 6 dice. Dice 1 to 6. How many times you are going to repeat? 729 times. Take 6 die, roll. Repeat this experiment for 729 times. Already I told that. So here, what is your P? When in a die there are 6 sides, your P must be defined clearly. How many times do you expect? At least 3 dice shows 5 or 6. By getting 5 or 6, your success. Getting 5 or 6, your success. So not getting 5 or 6 means failure. So your P value is equal to 2 by 6. Number 5, number 6, both of them can occur. Then it is success. So 2 divided by 3. 2 divided by 6 is 1 by 3. If you obtained P, Q is ready. You subtract from 1. So your P value is, and Q value is 1 minus 1 by 3. It is 2 by 3. We have obtained P value, Q value. Nothing more. We cannot done any calculation. Read the problem once again. 6 dice thrown 729 times. Out of 729 times, how many times we can expect? At least 3 dice shows 5 or 6. So your X value is 3. Probability of X equal to 3. 3 or above. At least 3 dice shows 5 or 6. You are going to find out the probability for X greater or equal to 3. First, probability mass function. Probability mass function is it is given like this. Probability of X equal to 60x. NCX, P power X, Q power N minus X. N value 6 because you are tossing 6 coins. You are throwing 6 dice. And X value is 0 to 6. Probability of success. Getting success means 5 or 6. Getting 5 or 6 means success. So required probability Actually, required probability is not asked. Expect number of times. Expect number of times that is asked. First, you find out the probability for x greater than or equal to 3. I can use 1 minus probability of x is less than 3. Because greater than 3 means that there are many terms. We can reduce to number of terms. X is less than only one term get reduced. If you are applying without using the complement formula, only one term. So 1 minus probability of x is less than 3. X is less than 3 means 0 case, 1 case, 2 case. How to find the probability of x equal to 0? How to find the probability of x equal to 0? In the previous line, you put x equal to 0. In the previous line, if you put x equal to 0, 6 is 0, 1 by 3 power 0, 2 by 3 power 6 minus 0. Likewise, put x equal to 1, x equal to 2. Let us take 3 power 6 common factor. If you have doubt, please ask. How to get 3 power 6 in the denominator? In the first term, here 3 power 0, second term 3 power 6, totally 3 power 6 outside. In every step, we may have like this. So probability of x greater than or equal to 3. Probability of x greater than or equal to 3 is 1 minus 64 plus 192 plus 240 divided by 1 minus 3 power 6 into 64, 192 to 240. Simplifying, 233 divided by 729. Probability for at least 3 dice source 5 or 6. Now we are going to repeat this experiment 729 times. So 729 into probability. If you are getting, it will give one number, that is the answer, 233. So out of 729 times, 233 times we can expect. We may get this is, if a particular exponent is repeated for some n number of times, capital N times, you multiply n into probability. So what is given is mean is given. Mean formula NP. NP is equal to 3. Variance formula NPQ. NPQ value is 4. So NP given, NPQ given. From these two equations, try to find out PQN. If you are going to find out PQN, your probability P must be lies between 0 and 1. And Q also lies between 0 and 1. And N value must be an integer, positive integer. Positive integer. If P lies between 0 to 1, Q lies between 0 to 1, and N is positive integer, then it is possible. Suppose if P is 1.5, probability 1.5 is meaningless. So the above statement is false. It is invalid. Right. Now how to get PQ value from this one? NP equal to 3. Here NP you substitute 3. Put 1 into, this is my equation number 1, this is my equation number 2. You substitute first equation in second, NP value 3. So the second equation becomes 3Q is equal to 4, Q equal to 4 by 3. 4 by 3 means 1.33. So 1.33 is not possible. P value, Q value always lies between 0 and 1. So Q equal to 1.33 is invalid. Given statement is invalid since 0 less than or equal to Q less than or equal to 1. Given statement is invalid. Invalid means not possible. It is false. It is not true like that. So we cannot find a binomial distribution with the mean 3 and variance 4. It is not possible. So this formula we got given in the previous class. I am going to use this formula to find a mode. Read the formula once again. In multiple choice questions, part A questions, the mode may be asked, because in just 1 line, 2 line, we can get the answer. If X follows a binomial distribution with the parameter N and P. If X follows a binomial distribution with the parameter N and P, then mode of the binomial distribution is done by mode means maximum probability like that. It is, there are 2 answers. One answer, m minus 1, m comma n minus 1. When m comma m minus 1, if n plus 1 p is an integer. So it is a binomial distribution with the n value 10, p value 1 by 2. If n plus 1 into p is a whole number, integer number, in that case, your mode is m minus 1. M and m minus 1. What is m? What is m? It is floor, the bracket. See the bracket. So this is called floor function. Floor function. Floor function means the integer just below this number. Floor of 1.3 is 1. Floor of 1.3 is 1. So the integer smallest, just smallest than 1.3. Floor of 1.8 is also 1. Floor of 2 is 2. Integer just below or same. If it is integer, you take the integer. Floor of 2 is equal to 2. Floor of minus 2.1. Floor of minus 2.1. Many students may commit mistake. The number below minus 2.1, the integer, is minus 3. Minus 3. See the real line. This is 0. This is minus 1. This is minus 2. This is minus 3. In the negative x-axis side, your values are minus 1, minus 2, minus 3. The minus 2.1 will be at this place. This is minus 2.1. So the number below minus 2.1 integer number is minus 3. Minus 3 is the floor function. So mode equal to m and m minus 1 if n plus 1 is an integer. N plus 1 p is an integer. Sometimes n plus 1 p is not integer. It may be a fraction, 5.7 like that. In that case, your mode is a unimodal, mode equal to only m. If you are getting m minus 1, it is called bimodal. Bimodal. Bimodal means two modes. Unimodal means only one mode. When we get bimodal, n plus 1 p integer. If n plus 1 p is an integer, we get bimodal, two modes. Otherwise, if it is a fraction, we have only one mode. So using this problem, yeah, multiple choice question may be asked. Very simply, you can get the answer. No problem. Compute the mode of the binomial distribution. Here, n p, n plus 1 into p. You find out n plus 1 into p. N plus 1 is 7, 7 plus 1 is 8. 8 into 1 by 2, it is equal to 4, an integer. It is a whole number. N plus 1 into p is a whole number. If it is an integer, then mode is m minus 1. What is your m? Your m is floor of n plus 1 p. N plus 1 p is 4. Floor of 4 is 4. So therefore mode equal to, since n plus 1 p is an integer, mode equal to, there are two answers you are going to write. m minus 1. M and m minus 1 are the mode. That is 4, 3. The mode is 4, 3. Once again, I repeat. Find n, find p, n plus 1 p. If n plus 1 p is an integer, whole number, then you have two answers for mode. The two answers are m and m minus 1. What is your m? Your m is floor function of n plus 1 p, floor of 4. Floor of 4 is 4. Floor function means an integer less than or equal to that number. Another problem of similar type. In a binomial distribution, mean 4. In a binomial distribution, mean is 4. Variance 8 by 3. Mean and variance are given. How to find mode? For finding mode, you need n and p. N plus 1 p value we need. First, we will find out n value, p value from these two equations. First equation, np equal to 4. Np equal to 4, you substitute in second equation. Substitute 1 into, that is np equal to 4. 2 becomes, in the second equation, you substitute np value 4. 4q equal to 8 by 3. Q equal to 8 by 3 into 4. 2 by 3. Q equal to 2 by 3. Then P equal to 1 by 3. P value 1 by 3. I need n also. Substitute p equal to 1 by 3 in first equation. In the first equation, if you substitute, then n 1 by 3 equal to 4, n equal to 12. I got n value and I got p value. Now I can find mode. For finding mode, you find out n plus 1 p value. Find n plus 1 p value. Thirteen divided by 3 is 4.33. 4.33 is not an integer. Not an integer. If not an integer, then mode is m. Otherwise m. Mode equal to m. Now what is m? Mode equal to m, where m equal to floor function of n plus 1 p. Floor function of 4.33. It is equal to 4. So mode equal to 4. So previous problem, we get 2